Greetings, humans, back in the saddle. Woo, it's good to be back. Similar figures, congruent figures. What's the diff? Let's see. Let's start with some definitions here. Similar figures have the same shape, but not necessarily the same size. So it's like when you're on your computer and you have the image of a triangle. It looks like this, and you're like, hey, I want to enlarge that triangle. So you like drag it, and then it gets bigger, but it looks exactly the same. Exactly the same. But as it gets bigger, the only thing that's really changing is the sides. The angles are going to be exactly the same measure, and that's kind of what defines a similar figure. The angles are congruent. However, the side measures change by a consistent ratio. It must maintain the same ratio. And that's where corresponding parts comes into play. Corresponding parts are the parts of, in this case, a triangle, but any shape or figure, the angles and sides that have the same relative position. So returning to our triangles, if you look at ABC in the first triangle, you can see DEF in the second, and you notice that AB kind of matches up with DE. But I say this sign here because these triangles were drawn to be similar, where angle A should be the exact same measure, this is the symbol for congruent, as angle D. Same angle, but it produces different side lengths. Okay, let's keep going. Congruent figures. These are figures that have the same exact shape, so much like our triangles, but they also have the same exact size. So if this one's measures 3, its corresponding side will also measure 3. If this one measures 1, this one measures 1. If this one measures x, this one will measure x as well. Congruent means same exact size and shape. Let's do some more problems. Let's take a look at this example. We've got figure ABCD, and it kind of looks like this, and this one kind of looks like this. So if you have the privilege of knowing that it's a rectangle ABCD, and this sign, remember this sign means congruent. An equal sign with the squiggly on top means congruent. If you would just have the squiggly, that would mean similar. But in this case, we've got figure ABCD congruent to EFGH. Now what I do is I would write it as it is. It would help me to have a picture. So I'm going to draw the first figure A, then B, then C, then D. You might ask, does it matter where you start? It doesn't matter where you start as long as you start the same place with the next figure. So if we started A, B, C, then D, let's start E in the same place we started A, and then let's put F in the same place we put B, G, and H. And the reason I must draw it like this is because it tells me in the original statement of the problem that that's the corresponding idea with our picture. So here we have it. Is B corresponding with angle F? Now you can look to the picture because you've drawn it based on the words, or you can look at the words. Right now, I think it would be easier to look at the picture. Is B in the same relative position corresponding as F? Yes. Okay. Our line segment EF and AB corresponding sides, do they match up in the same relative position? Yes. How about angles C? Angle C is right here. This one with two little arcs in it. Is that the same as angle H? No. You can see it clearly from the picture, and you can actually see it in the words up here. Angle C, is that the same as angle H? No, they're in different position. But remember, if you have congruent figures, that means that all of these angles, G is the same as C, B is the same as F, they're exactly the same size and exactly the same shape. AD is the same exact length as EH. All right, let's move on. Now, if you're given two figures, how can you tell if the figures are similar? Well, similar figures must have corresponding sides that are in the same ratio. Okay? The angles must be the same, however, their size can be different. Though it looks like these are relatively close in size, you can see as labeled, they're very different in size. The first, ABC, has side lengths 3, 4, and 5, and the second has side lengths 16, 12, and 20. I guess the first thing I would ask is, which sides are corresponding? Does AC match with EF, or does it match with FD? I don't know. Well, let's think about it for a second. AC is the side that's the shortest in the first triangle, and FD is the side that's the shortest in the bigger triangle. Okay, so it looks like AC corresponds with FD. Cool. What does that mean, though? Okay, that means 3 must match up with 12. And in order to be a similar figure, all the side lengths must be maintaining the same ratio. They all have to change the same way. Just like you drag the image from the computer, it stays the same ratio as it gets bigger, so it looks exactly the same. If one side got obnoxiously big as you dragged, it wouldn't look like the same picture at all. So if these things are indeed similar, 3 must match with 12 in the same way that 4 is the other leg of this right triangle, so that must match with the 16. And again, we're pulling from the small one to the big one right now, seeing if they're within the same ratio. And 5 from the small matches with or corresponds with 20 from the big. Are all these the same ratio? If so, what is the ratio? As you simplify these ratios, divide the top and bottom by 3, you'll get that. Here, divide top and bottom by 4, you'll get that. And lastly, divide top and bottom by 5, and you'll get this. And you can see it's a 1:4 ratio from the small triangle to the big triangle. That means these things are indeed similar because corresponding sides are proportional or maintain the same ratio. Okie dokie. Cool. So as long as you match up triangles from small to big, or are consistent and say from big to small, the triangles will be similar if the ratios between them are the same. If A matches with B and C matches with D, and that's the same ratio all the way across the board, then those triangles, or any shape for that matter, are similar. They must have the same angles or congruent angles, but the ratios of their sides, the corresponding sides, must be equivalent. Okay, that's that, and that was Matt that interrupted us. Anyway, hey, be quiet, I'm on the video. Okay, bye-bye. Do your homework.